These are created from data that I've gathered from Twitter. So I'll show you how I gather that data and then how I use that data to create a graph. On F-Secure's News from the Lab blog, I published an article called Searching Twitter with Twark. And this article contains the code for a tool that will, given a command line parameter, perform a Twitter search over the last 7 days and save a bunch of different data. One of the files that it saves is a CSV file containing an edge map that can be used or imported into Gephi and used to create these visualizations. So what you're going to want to do is copy paste this code into a file. And also, once you've done that, you're going to want to, if you haven't done it already, create a Twitter developer account and create a Twitter app and get these 4 values. And then you're going to want to edit the file and put those values between these quotes. So once you've done that, you'll end up with a Python file here. I have here the Python file that I saved is called search2gephi.py, and so I copy pasted the code in there. I actually edited it because it contains a function to download images, and I didn't wanted to do that in this demo, so I've just omitted that piece of functionality. And I also edited the file and included my own authorization tokens. So then we'll just run the file. So Python search to Gephi, and then a search term. I'll use PyTorch. And now this script will go and collect tweets from the last 7 days with the search term PyTorch in them. And it shouldn't take all that long. I ran this before and there was about 2,000 tweets. Yeah. So it saved the data into a directory with the same name as the search term. And you'll see it like it's created all these different files. For instance, here's a file with hashtags and the frequency at which the hashtags were seen. Also, there's a file that contains all the URLs, which might be interesting to look at. But the one that we're interested in is this user graph.csv. And here we have basically an edge map. So this source is the Twitter screen name of the user that posted a tweet. Target is the Twitter screen name of a user mentioned in the tweet, and weight is how many times that occurred. So for instance here, AI Workbox mentioned Seb_G twice. So the next thing we'll do is import this CSV into Gephi. I already launched Gephi here, and we'll import spreadsheet. And I'm already pointed at the right directory. We get that CSV file. You can go with all the defaults on this import. It should say edges table. And the weight it assigns as double. You can change it to integer, but I won't bother. It doesn't really make any difference. So once you've imported it, the first thing you want to do is a little bit of setup. So go to the Data Laboratory tab. And here you want to copy data to another column. And you want to copy ID to label. This way, these labels will actually show up on the output. Then go to the Overview tab. And you'll see immediately this messy square of nodes and edges. So the first thing we'll do is we'll color these nodes. So we'll run this modularity algorithm using the defaults. And here it shows that it found 68 communities, and this graph here is the size distribution of those communities. So the largest community was over 200 users, but there are a great deal of communities with just a few users, maybe even just one or two. Here, go to this one, which is selected by default. This is for node coloring, and click partition, choose attribute modularity class. Now by default, the color palette only contains colors for the highest 8 communities, but we want to color them all. So open palette, generate, unclick this limit number of colors, choose a preset. I like this intense one. Click generate, and if you're okay with the colors that it's selected, click OK, and then click apply. And you'll see that immediately it's colored these nodes. In order to show labels in different sizes, so it emphasizes labels for interesting nodes, we want to set the node sizes. So what I like to do here is click run, or run this average weighted degree algorithm. And here it shows us degree, which means both in and out degree, and it shows us the distribution of those values, and it also shows distribution of in degree and out degree. Let's go to this 2T's thing here and select ranking, choose an attribute. Weighted degree looks good, and the minimum size can actually be set to 0.2. That's the smallest you can set it to. Let's set the maximum size to 2 for now, and let's choose this spline. This is a nice default way to go about things, and you can change things later. When we click apply, we won't see anything on here because we're not showing the labels yet. But now we want to get this square mesh into a nice shape. Here we have 1,235 nodes and 1,955 edges. That's not a very big graph, but what I typically like to do is start with OpenOrd, and just I'll zoom out a little bit so you can see what it's doing. So just run that, and what it'll do is it'll run these different phases. There's a liquid phase, expansion, cool down, crunch, and simmer, and here at the bottom you can see the progress bar. So that first liquid phase, you can see it just moves things around, and then when it gets to expansion it starts to form these clusters, and then it'll shrink them again, and we'll end up with this thing. It's almost done now. Now if we go into preview already and select, I like to select the black background preset, just everything as presets, and click refresh. This is what our graph looks like, and we can see already that there's like a quite high concentration of labels right here, but the labels are already quite small. So let's make a few adjustments. Firstly, let's change this layout, and let's use Force Atlas 2 and run that. And you can see it like sucked everything in, but there are still nodes out here really far away, and we've got this one cluster that's kind of far away from the rest. So let's use the stronger gravity option, and when using that, it's good to change the scale. Let's start with a scale of about 200 and run that. As you can see, it created this nice spherical object where everything can then be seen without having to zoom out really far. Let's have a look at that in the preview already. So let's just click refresh here, and reset zoom should zoom in. So it already looks pretty nice. We can see the labels of some interesting nodes on here. Let's try playing a little bit with the label size setting, and at this point this is what it's all about. So I'm going to make it a little bit bigger. I'm going to change the scaling to 500, and I'm going to change the max node size to 4. So let's just apply that one first and then run this. You see it got a bit bigger there. You can already click stop, and then let's go and preview that again. Now, of course, it got bigger, so we need to like reset the zoom. And here we can see like that there's less overlap with these labels now, but they're a little small, so make them just a little bigger. Let's try maybe 6. And we just refresh that. And now they're a bit big. So this is all about massaging these values until you have something that looks nice. And this is why it's difficult to programmatically generate this stuff, because every graph is going to be a little different. Again, it's a little busy still, but it's sort of okay. Maybe half a point smaller on that. So anyway, at some point you're going to be happy with the way it looks. And what I typically do at this point is take a screenshot, because the export functionality, I've not had much luck with it generating graphs that are that have these very nice fine lines. We'll notice actually here that the edges are a little bit difficult to see. So let's change this, and we just change this thickness value from 1 to 2. Let's try that, see what it looks like now. And now you can see that the edges are much more visible. So yeah, at this point then I'll just use Command Shift 4 on a Mac. It gives you this cursor, and I'll just draw a box around it, take a screenshot. Here it's saving it. Yeah, anyway, this screenshot is then just basically directly screenshotted from the app, and it's going to look pretty nice like that. So, I mean, these steps that I've showed you are just a getting started guide. So this is the basic steps that you're going to want to take once you have your data and you import it in order to get something that's nice looking. There are plenty of other layouts to try. You can try changing also the size of the nodes. This one will allow you to change the size of the nodes again using this ranking. But when you do that, then on the preview, we'll also change the size of the label. So you're going to need to play around with that a bit. There are other things you can do. For instance, if you don't want to see all the edges, you can actually filter by edge weight. So here, go to this filters tab and drag this edge weight into queries. Then click filter, and if you drag this setting, it will actually start omitting edges that are below a certain weight, like you can see here. Then if you go to preview, you'll notice that those other edges are now not being shown. And this can be useful if you just want to find very strong connections. That's about it. Enjoy playing with Gephi and make some nice graphs. Thanks.